Oh, it's cold outside. And the paint's peeling off of my walls. Well, you know what that means. Time to fix another synthesizer. Now, this synthesizer is a bit of an oddball here. It's a Roland SH-2000. And I think it might be the first analog synthesizer we have on this channel. And this synth is here on the bench today, courtesy of my friend and the other half of our band, Greenside Drive, Mara. So yeah, thanks again, Mara, and we'll get this thing fixed right up. All right, first we'll do a little sound test. Try fuzz guitar 2. Oh, she's sick. Oh no, nuts. So, as you can hear, this thing's cooked. As you can see, this is a preset synth, mainly. We got some controls on the left side here, and she ain't sounding too good. Also, check out this weirdness on the side. Yeah, someone put in these massive Amphenol connectors. I guess they're D-sub something, like 37, 50, who knows. So we got 2 here on the side, and 1 here on the back. And yeah, those are not factory. So I bet someone's been in here. Okay, so let's open her up real quick. Oh. Yeah, see, look at that. 2 different screws. Definitely a hack job. Oh, that's nice. See, now this is something I really do admire. It's just 2 screws on the side to get in. There actually looks like there should have been 2 more back here. But yeah, just 4 screws. The top comes up, and you can already start servicing it. That's loose. So taking a look at the service notes here, looks like this board is the 2nd voltage controlled oscillator, and this is a 2nd voltage controlled filter. Yeah, so I guess this thing has 2 oscillators and 2 filters. Oh wait, no, it looks like 1 VCO, 1 VCF. I think these might just be the 2nd revisions of these. That seems to make more sense. But yeah, let's continue our journey into the center of the synth. It looks like everything inside of here bolts in from the bottom. Now, I don't know if you can see well over here, but it looks like the bottom of these switches have cotter pins. So you can see this one doesn't come off, but this one does. So that will be on the list of things to fix. New cotter pins for the switches. Yeah. Ah! All right, let's see what we got here. Looks like our control unit assembly lifts right out. And yeah, just unplugs from the rest of the synth. It's a very nice modular design. And yeah, this has definitely had some rework done to it. I can see right here, here, and here, someone's definitely desoldered these chips and soldered them back in. You can tell because someone redid the soldering here using a lot of flux, and then tried scraping in between the pins. That's why you're getting all this brown crud right here. And it looks like when they tried it over here, they used a bit too much heat and lifted some of the pads up. Just wanna see something real quick. I mean, yeah, I can't fault them too badly for it. It's a bit of a hack job, but it works. But then we have this resistor here that looks burnt to a crisp. It looks like a 100 ohm resistor maybe. So we'll bring this over to the soldering station to see if we can clean some of this up and potentially replace this resistor. And also do some exploratory surgery. If these chips have been socketed, I highly doubt the wiper contacts on said sockets are still gonna hold up. We also have this cute little power transformer over here, and the main power supply board. My guess is this is gonna be fine. Now we'll take the keyboard assembly out. And it connects via these 2 cables to the control unit assembly. I've got to admit, it's a pretty nice feeling keyboard. And if we flip it over, it's a number of switch reads and bus bars. These have most likely oxidized and are definitely going to have to be cleaned. I find it really interesting that there are two bus bars here, a top one and a bottom one. I believe this has something to do with the note priority, where if you play a note down here and then a note up here, the note up here will cancel out the one down here. Since it's a monophonic synthesizer, you can only be playing one note at a time. So yeah, this might be their engineering solution to top key priority. Also, did I mention that this thing has aftertouch? You see, if I push down a note here, this little bar moves. If I push it down harder, it moves even further. It looks like there's a Hall effect sensor glued right here on this plate, and this is the circuit board for it. Aftertouch in Roland parlance is known as touch effect control, where you can control things like wow and All right, the plan for the key bed is taking out all the keys, washing them repeatedly because they're absolutely filthy, and cleaning the bus bar contacts. The felt acting as the key bushings doesn't feel that bad, and also I don't have any strips of felt lying around, so we're just gonna leave that be. Honestly, Roland, sleeping on a pretty cool keytar design here. Ooh, ooh, wow. What are you? Reading the service manual. Roland, you've confused me yet again. But what do the boards do? Okay, these two cool boards. This one, right by VCO2, seems to be some sort of wave shaper and mixing section. So you can see different waveforms and footages printed on the backside of the PCB. And this guy here seems to be our ADSR, or our envelope generator. And this board here seems to be all of the routing for our presets. This giant diode matrix. And it does some audio signal routing. It's a mix between a motherboard and a preset board. Now let's talk about these bodged-in connectors. I thought these things were going to lead to something so cool. Ugh. But it turns out one of these connectors isn't connected, and the other connector goes to this connector. Doesn't go anywhere. And for this connector back here, it just breaks out into the preset switches. Now, I don't know why you'd want to do that. Maybe if you had something like this in like a set list for a live gig you were doing, and you didn't want to remember what preset you had for which song. Like, oh, I'm gonna play song A. Then song B. Then song C? I don't know, man. That's weird. You got them all right in front of you anyway. And by the way, no, you can't combine presets. You only select one at a time. Also, if you select more than one, it picks the top one, just like the keyboard. So that's pretty cool. But yeah, I was kind of hoping one of these breakouts would control the VCF or VCA or something. Though with the spare connectors over here, we might be able to wire something like that up. Alright, so the first thing I'm doing here is taking these little paddle switches off. Now, if you get a really cheap watch repair kit, you can find these little tools in them. And I'm using them to help push out these cotter pins. And I'm also using these flush cutters to help pull them out the rest of the way. Now these pins are a little strange because they're just these rolled up pieces of metal. But yeah, I'll see if I can find a paper clip or something to replace the missing ones. Alright, let's give our switch caps a little bath of dish soap and warm water. I then spent an evening cleaning the switch caps with a toothbrush and letting them sit to dry. Whoa! Why would someone do that? And yeah, same thing with the tape over here. Very strange. Ew. Ah. So someone decided to glue all the switch caps onto the switches and glue the switches into the chassis? Yeah, that one's not coming off. You know, I'm wondering if this is a replacement switch, since it's different from all the rest. Yeah, so this one seems to be angled up and angled down, unlike this one, which sticks straight out and then gets angled down when you turn it on. Yeah, this one seems to be angled more like your traditional single pole double throw switch. Another weird hack job. Before continuing, I took the opportunity to vacuum out the chassis, since it was covered in dirt and dust, and then turned my attention to that weird replacement switch on the front. And in the meantime, let's see what we can do about our loose switch here. Now, I can see what they did here. I can even see why they did here. But it's just such a crappy fix. They screwed in the top of this switch, lined it up, and then put glue all over the back down here, just because the hole in the case and the hole on the switch don't quite line up. But it's not that bad, actually. You see, we can just take a 3M screw here. Here's the other driver. And the switch goes in and lines up pretty good. Now we've got our Jello shot, simple green, and we'll just clean off the area surrounding the switches. Now finally, as the electrical portion of these switches is concerned, we'll spray down the contacts with deoxit, and same for the connectors up here. Alright, so here I am reinstalling the switches, and as I was going through a picture I saw online, those 4 on the left there are looking different than these. Yeah, so it looks like the previous owner here cut down the stalks on the switches, so I'm not going to be able to mount the paddle kind back on here. So we'll just keep these chrome blocky ones. Also, these 3 switches here are the wrong color, but they still work, so that's not too big a deal. Now my fix for the missing pins that keep the switch keys on are these. They're 2.54mm pin headers. They're the kind you can get for electronic work and that will go into breadboards. Now about 4 of these makes a pretty good replacement pin for one of these. And it gives the keycap a pretty tight fit. So yeah, just use 4 2.54mm pin headers. And there we go. I don't think that could have gone better. Except for this guy up here. Just a hair taller than the rest. And these 4 down here, I'm just gonna leave them as is. I could glue them, but I don't want to make replacing the switches or the switch caps a nightmare for the next tech. So yeah, no glue here. Later on, the switch caps kept falling off, and I couldn't find an elegant way to adhere them to the switches. So I'm gonna have to go back on this one. I did end up gluing them in. After that, I hit the switch caps with some Novus 3-stage polishing compound, then finishing them off with some Windex and some Gibson guitar polish. I then decided to address the issue of the side coming off, while I had the synth torn down this far. There, I decided to apply a large helping of wood glue. Alright, here we have the key bed, and I'm gonna start by taking the keys out. Where did my pliers go? I lost them in the war. Well, you know what? Fine. I don't need you or your stupid pliers. I miss my pliers. Ha ha! There we go. Whew. Now, I've never exactly seen keyboard construction like this. The springs and everything, I'm used to. It's the pieces of fabric I'm not. Yeah, these keys are disgusting. So what, did someone just like cut up their belt and put it in this keyboard? Is this factory? Do you guys know? Oh, look at that. Look at these little guys. See these? Ugh, all right. Ooh. Ugh. Ugh. All right. So we have our keyless key bed, and it's disgusting. Got like 50 years of gross in here. And now I'm gonna focus on trying to get this front plate off right here. Helps to use the right screwdriver. Looks like there's supposed to be a screw over here that we're missing. And that comes right off. These screws off here. Yeah. God, I'm getting crap all over me. You know what? I've got a solution that just might work. Vacuum cleaner's dying. Are the paper bits important? Can anyone tell me? It just snaps right back in. That's good. All right, this bit back here is for the aftertouch. Yeah, I think I'm gonna remove all the key guides. Get those clean. Ooh, before I go any further. 1, 2, 6, and 7. No guarantee that marker is gonna stay on. Ah! Throwing all the key guides in the clean me pile. Now I think I'm gonna leave this whole assembly in place. And let's say the last part that comes off is the aftertouch bar. Aftertouch parts go in here. Make sure those 3 washers are kept together. Man, I don't like that. You know, I think the aftertouch bar should stay, and I'll just clean this part by hand. Here I gave the keys and key guides a little bath in a mixture of dish soap and simple green. I also had to clean out any old grease that remained between the key guides. Alright, and I've got the keys cleaned up here. They're still a little yellow, but they look and feel way better than before. Now, I find it really interesting how, like, this thing tells a story. Clearly, the previous owner was a smoker. And at one point, when they were doing some sort of mad keyboard solo, they burnt these 2 keys over here with a cigarette, and tried to sand this one down on the side. Now yeah, compared to the rest of these keys, this one's extremely discolored. So let's see if we can bring back some of this glossy black finish. So I think the plan going forward here is going to be to remove this bar, clean the whole surface, replace the foam, and then see about cleaning the bus bar and contacts. Ooh, it's fighting me. Actually, that can stay on. Nice. So it looks like this bit of metal here is only for supporting the magnet that runs by that Hall effect sensor. And this one here is for aesthetics. It also provides a hard limit for the bar to stop. Can let go now. You too. Come on. There we go. Yeah, there's nothing I really wanted to do in terms of these tabs here, because it looks like it's just a straight piece of metal that sticks right up and was bent over at the factory. Of course, if I unbent it and then bent it back, it would cause stress in the metal. It would cause that to break. That would be a nightmare. Let's not deal with it. It's so gross. Actually, first let's remove this old foam. Yeah, trust me when I say this foam isn't that bad to remove anyway. One of my first analog synth restorations was a Realistic or Moog MG1. And yeah, they just cake that thing with this foam that turns to goo. It's freaking disgusting. I remember I spent like a whole weekend in my parents' kitchen trying to get that stuff off. Oh yeah, she'll pass muster. Nice. Yeah, we're gonna need a double layer of that. I'm willing to call that good enough. You know what? You know what? Let's see if we can give this aftertouch device a little bit more resistance. I wonder if these are factory, because not much else on the synthesizer has been. There are actually 4 washers over here and 3 over here, so someone's definitely been tinkering with this. 2 and 2. Yeah, that's adding a little bit more resistance. Yeah, you know I'm out here using the Elmer's school glue. If it works, it works. Goes for both the felt and the glue. I think we're gonna want to see a bit more rigidity in the aftertouch. All right, now let's look at the other side. I need that unscrewed and that unscrewed. Yeah. Let's see if we can remove these bus bars. There we go. All right, and that's 1 bus bar. And I have no idea if this plug was glued in at the factory or if the previous owner glued it in. I'm debating whether I should glue it back in or not. But yeah, let's see what we can do about this. And the trek out to the shed begins. Join the Navy, they said. See the world, they said. Well, at least get some pretty good boots out of it. And how cold is it out here? Yeah, cold. Yeah, We got any 1000 grit in here? And how old is this stuff? I'll settle for some 1200 leading into 2500. And the drill. So what I was thinking was, I call it the Roto-Rooter. It's actually too thin to get a good grip on. Oh well, anything's worth trying twice. We'll hit it with 2500 grit, and then wipe it down with a bit of deoxit. Hey, look at all that. We'll go ahead and tackle the other one. Let's now give all the contacts a spray down. And we'll put the bus bars back in. And now we look in here. All right, I've got the key bed all cleaned up, and now it's time to reinstall the keys. But before that, we have to reinstall this metal bar here. And as I was looking at the service manual here, you see there should be a felt here on the underneath part of this lip, and some running along the bottom where this tape is. And we've got it here underneath the lip, but yeah, none at the bottom. Luckily, my wife had some leftover fabric from reupholstering this groovy mid-mod chair that we have up in our living room. So I think we'll glue it in right about here. And there we go. That should make some pretty good key bushing material. Did you forget about these? Yeah, me neither. Now, if only I could remember where I put the other screws. Hey, I found them. And I am shocked. I can't believe I didn't record myself taking off the cheeks. And for a second there, I thought I'd be saved by the video footage. There we go. Is it short than long? Or long than short? It is long than short. The long screws in this pile attach this piece. Next we'll throw these key guides back in. Huge props to whoever designed these. They got little guide pins at the bottom, so you can't really misalign them. You know, I'm starting to kind of doubt that these washers are factory. It also looks like the spring tabs here at the end might have had a matching pair here as well. Think anyone would notice? Oh, it's got to be like that. I'm starting to think that the previous owner didn't want aftertouch and just wanted touch. Oh yeah, that feels much better. But before I install the keys here, we'll throw a little lithium grease into the key guides. Let's pop the keys back in. And these keys, they feel so dead because we haven't put any springs in them. And we'll start back up with the key springs. As soon as I can find my pliers. There they are. Ye think you can be besting me, pliers. I've been a fool. I don't even need the pliers. What am I doing? Ah! Do I need the pliers? No. But do I want the pliers? I will say, the keys, they're a little bit more mushy, and they have less travel. They seem to be pushing on the contacts all right. Yeah, I can't really complain there. All right, we'll just screw our preset indicator plate on. Alright, I think the key bed and key assembly is done. Alright, now before I put the key bed back in the synthesizer's chassis, I have to install these two boards. So I'll just give them a visual inspection. First we'll start out with this voicing board here. Just on first glance, I love the way the traces curve and flow throughout the board. It gives a real art to PCB design. But from where I'm looking, it looks like this pin right here might have a cracked solder joint. There's a closer look at that. I'll just hit it with a touch of solder. Might as well do it for all the joints here. And I'm happy with that. Our next board here is our envelope generator. Now, the only part of this board that gives me pause is this trace right here. It looks like it might have been subjugated to corrosion or heat damage, so we'll just perform a little continuity test. And that seems to be all well and good. I've just now sprayed the contacts down with deoxit, so let's put these back in the main board. Okay, now the key bed goes back in. Alright, that's starting to take shape. It's starting to look like a synthesizer again. Now I've got here the VCO and VCF cards. I did a quick visual inspection and sprayed their contacts down with deoxit. So let's pop these back in. And while we're at it, let's chuck in some new screws here. This leads us to the last and hopefully final unit that we have to work on, which is the control unit. Now, I think this might be a bit of a problem child for us, since it has this whole aftertouch section that didn't really seem to work, and it seems to act as a central hub in some regards, given all the connection points. So yeah, this thing's filthy, so let's take it to bits. Right off the bat, this side had a washer, this side didn't, and we were missing a screw down here, so somebody's definitely been in here. They also glued down the faders, which was kind of annoying. Looks like the LED has to be desoldered here and right here. Man, what a hack job! Didn't even use electrical tape. If it works, it works. Alright, we'll toss that aside. I love it. Now what I'm not loving is how bent these fader stalks are. And this foam. It actually doesn't seem to be in that bad of condition. I might just leave it. It kind of reminds me of the foam that's in the realistic MG1. They had this stuff near every single slider and it got way in there, disgusting, melted. I had to take apart all the sliders. It was a nightmare. I haven't seen a single socketed chip on the Roland. So these must have been done after the fact. Oh, and that explains all the wires. When I first opened it up, I saw these old pieces of tape falling off all the wires, and they all had numbers on them. So it looks like the previous owner went in and numbered all the connection points. Pretty clever. Wish I'd thought of that. Yeah, but who needs that? We got video footage. Ooh, who wants to bet that's the LFO? I know that back in the day, to create more stable oscillators, they'd find two of the same transistor with similar HFE, which is a measure of gain and frequency response. They pair them up with each other and then glue them together. This is because if both of the transistors are thermally bonded, meaning that they're operating at the same temperature, it's harder for them to drift out of tune. And of course, for a bit of good measure, we'll lift these out of their sockets, spray them with a bit of contact cleaner, and chuck them back in. I've just gone through, used deoxit D5 on all the switches, used deoxit F5 on all the potentiometers and faders, cleaned all the fader caps and knobs, and given the front panel a bath. So let's start putting it back together. Oh yeah, I also made a new switch dust covers out of gaffer's tape. Just gonna reattach these wires. Actually, no, I got a better idea. She's putting up a fight. Well, it might not have been the modular connector we wanted, but it's the modular connector we needed. This is a crispy, burnt-up guy here. 100 ohms? Oh, yeah, that still checks out. Alright, she seems pretty solid. Let's pop her back in the synth. Alrighty, we've got everything in a semi-put-together state here, so let's power her on and see what she does. Alright, we're gonna select a preset here, so we'll do popcorn. Alright. Got the old Frogman preset. Oh, manual filter. Nice. Try a fuzz guitar. And maybe with a little portamento. Nice. Let me go through all the keys real quick. We'll turn on hold to prevent the envelope from closing and run our way all the way up the keyboard. You know what? Let's mark these problem keys. Alright, I'm not really seeing anything repeat across the entire key bed, and it doesn't really seem to be like entire sections of keys. Maybe these three here. So I'm thinking it's not really a problem with the sample and hold circuitry in here, but rather the key bed itself. So let's take the key bed back out and see what's wrong. Alright, as you can see, this is the underneath of the key bed, and what I've been doing is going down the keys and bending these leaf contacts back into place. So when I press down one of these keys, you can hear it initially plays the right note, but then when I release the key, it defaults down to the very bottom note. Now here's what these two bus bars do. The one at the back is your note on, note off, and the one up front here is your note pitch. So what it looks like it's doing is contacting the pitch bus bar first, then the note on, but then when we release the key, it's letting go of that pitch bus bar first, then doing the note off. What we want is that sequence to happen in reverse at the end. Note off first, then pitch. So by adjusting these leaf springs a little bit, pushing that back. I've pushed the note on leaf contact back a little bit so that it turns off sooner, which means by the time it releases from the note on / note off bus bar, the leaf contact in front of it is still contacting the pitch bus bar, which allows time for the synthesizer's sample and hold circuit to kick in. Thus, our release is the same note as the rest of the envelope. Now let's put this thing back together. It was then during this putting things back together phase that tragedy struck. Now, as you can see, the SH-2000 is in pieces on my bench. And you might have the same question that I had 22 hours ago. The hell happened? Well, I was putting everything back together, I was testing it, and then I noticed a wire popped off over here. So I soldered it back on, and then switched it back on, went to test it some more, and suddenly the VCO was dead. So here I am scratching my head thinking it was like a loose connection or something on the board. So I took the main board out, resoldered all the connection points on the back, resoldered all the connection points on the VCO and VCF, and did the same for the control board. But still, no dice. So I dug into the service manual and began probing around. The VCO has this really weird oscillator design, which I should be explaining right now. No past video clip of me, how about you explain it right now? Okay, fine. It's actually really interesting. So I started looking at the schematic for the VCO and I was like, oh, hey cool, there's a 555 timer in here. It's like running as a astable multi-vibrator, which is like the electrical engineering equivalent of Hello World. You know, blinking a light with a 555 timer. So I was like, cool, classic circuit, got this. But that's wrong. This 555 was set up in monostable mode, so it was acting more like a one-shot? Wait, but how does that work? So then, digging past a slew of op-amps and transistors, I see a triac? You know, that thing you use to dim lights? I'm like, what the heck is that doing in there? Was it acting in some sort of weird current limiting function? But nah, check out that capacitor-resistor pair, and that transistor pulling the signal low. So I look through the triac's datasheet and see this weird oscillator configuration, and then I'm like, oh, this is some newfangled old world strangeness. And apparently that was a cheap way of making a ramp core oscillator in the 70s. So you have this triac oscillator block that triggers the 555 as a one-shot, feeds back into itself, and then you get your voltage control piped in through these two op-amps, and the control voltage pin on the 555 for vibrato. And last but not least, your output transistor here takes the output of your oscillator section and slams it between the 15-volt rail and ground in order to produce a square wave. So yeah, just wanted to point out this super alien design that's pretty wacko from a modern day perspective. And back to the repair. And I'm getting this high frequency oscillation out of the thyristor. So it's oscillating and doing its job. But at a couple hundred kilohertz? No way. Nah, that ain't copacetic. So I'm thinking, okay, I'll worry about that later, but right now I'm seeing a constant 15 volts coming out of the VCO output. I start looking at this Q105 output transistor here and realize that there's some sort of internal short that's pulling everything up to 15 volts. I start digging through my component drawers and find a 2N3906 PNP transistor. That seems to be a pretty good replacement part for this 2SC733. The only difference is that the base and collector pins have to be crisscrossed like that, because the pinout's just a little different. In addition, I replaced the 555 timer and two of the 4558 op amps, just because I have a stockpile of those. Oh yeah, the 555 turned out to be faulty as well. So now I'm getting a high frequency signal out of the VCO out pin sometimes, and I start probing around a little bit more. I start going down this row of pins here, and then I stumble across this purple wire here. It's at like -10 volts, and I'm like, that doesn't seem right. Just an inkling, a hunch. The control voltages seem like they're positive for the most part on the board, so I desolder it, and then the VCO springs back into life with this constant tone that isn't affected by the keyboard. Though we still have this green wire hooked up to pin 6, which should be the keyboard control voltage. But yeah, it ain't doing anything. So then I have to take apart the control module, and it has like a million screws in it. One of these wires breaks off and then hits one of these wires, which causes the magic smoke to escape our replaced 555 timer. At this point, I'm like going through and checking all the connections, making sure they're really soldered down, because this seems to be a major fault of the SH-2000 right here. Or rather, a major fault of the technician right here. So yeah, I'm at a bit of a loss. I'm like soldering this back in, it pulls voltage down, nothing happens. Control voltage isn't doing anything. So I start from the keyboard in and work my way over to this op amp. And I'm like, well, it never goes above 0 volts. And it's rail to rail, or rather connected to the positive and negative rails. It's a 4558. I don't think it actually goes rail to rail, which leads me to probe pin 8 on the IC, which is your positive supply voltage in. And could you guess what I found? This fault actually kind of harkens back to the last time a repair was done on this, in maybe the 70s or the 80s. It looks like whoever was fixing it put a little bit too much heat into the pad and it lifted from the PCB. I guess it was marginal enough to like sever the trace here, because yeah, this pin wasn't getting any voltage. So I just soldered in a jumper to kind of reconstruct the trace here. And I had to do it with a few more of the pads as well. But with that all said and done, It seems to work now, so we'll now really be putting it back together. We'll button it up quick before any more problems arise. Wow, can you believe it? It's all back together. And I think it cleaned up pretty well, if I do say so myself. So let's switch on the SH-2000 and see what it sounds like. All right, we'll start out with tuba. This audio is gonna be really bad because I don't have the mic connected. I was gonna go demo the synth, but then I realized that I hadn't tuned it. So we'll be setting the master tune of the VCO with this potentiometer here, and the keyboard scaling with these two pots. Yeah, I'm happy with that. Alright, now she's pretty and has a beautiful voice. Just like my wife. So now let's switch her on and go through the presets. First we have tuba. I really like the low end on this thing. Trombone. Trumpet. Saxophone. Bassoon. Oboe. Flute. Oh, that's a good one. And the last one we have in this bank is clarinet. It's got a nice kind of triangle wave sound. Also, one thing to note here is how some of the presets, if you hold it down, it gets more vibrato over time. But yeah, I think a lot of these brass instruments have kind of a Casio vibe to them, and the woodwinds are pretty solid. Next we'll do cello. Yeah, there's that vibrato kicking in later. Violin. Bass guitar. Oh, that's a good one. That's a good bass sound. Woo! We have a wine guitar. Another cool thing to note here is some of the presets that have modulation you're able to control. We have banjo next. Fuzz guitar. It's a pretty good lead sound. And let's check out fuzz guitar too. And how do I make my guitar sound like that? Good preset, just not all that accurate. Here's piano. Harpsichord. Accordion. Vibraphone. And here's xylophone. Oh, it's that filter sweep that gets me. Call it space xylophone or something. All right, now we're getting up to the more synthesizer-y tones. Here's singing voice. You know, because you're always saying like, wah, 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 if you want to sound like one of the adults from the Peanuts cartoons. Here's whistle song. We've got popcorn. Guess what inspired this one? Space read. So it's like xylophone with a slow attack. Of course, we all know what a planet sounds like. Heck yeah, Frogman! Let's go! Listen to that filter sweep. Next up we have Funny Cat. Next it's wow! And finally, everyone's favorite preset. Wind. Okay, so we've demoed all the presets here. So let's talk about the controls now. There are two main sets. We got this top portion here, and this control section on the front here. First we have repeat. So I'm gonna select a preset here, and as you can see, it's just triggered normally. But activating the repeat switch causes a re-trigger while I'm holding the key down, and the rate of that trigger is controlled by the modulation rate. Now, with presets with pretty long decay times, such as Hawaiian guitar, the effect is less noticeable, especially because the Hawaiian guitar has that vibrato going to it at the same rate of the repeat. And if we slow it down, you can start to hear that retrigger, though that vibrato sound is kind of slowed down and makes the signal more wavy. But yeah, you can really notice it with presets with really short release times, like popcorn. Next we have long sustain. Again, if I have a preset with a short sustain time or decay time, come on guys, where in the envelope are we? Yeah, so presets with a short decay time now have that extended out longer with the long sustain switch. So I guess in our ADSR envelope, yeah, that's pretty apt. It raises the sustain. So it's just attack, no decay, sustain, and then release. Last, we have the hold switch. Basically, it holds the key trigger closed, and your note has maximum sustain and release. How's that for a preset demo? Next, let's focus our attention to the controls up here. First, we have modulation, which you guys have seen before. And we have our filter control section, which is operated by the filter manual switch. We have the modulation amount. We also have our cutoff frequency. And our resonance amount. Honestly, the filter controls don't give you full control over the filter, and a lot of it is based on how the preset's configured in the first place. You see, we can hear the filter closed all the way on clarinet, but not on violin. And of course, the filter is affected by whatever preset envelope that, well, the presets have. After that, we have our portamento section. Which has two modes, on and slow. We have our volume control. I'm not really sure what that does.
Unmistakable, can't miss it, volume knob.
What is that controlling?
Our transpose switch. And the function random note, which you can have set to auto, which is also controlled by modulation, and key. We have our pitch control here. Just for fine-tuning adjustment. And last but not least, let's touch upon the touch effect control. The touch effect control, or aftertouch, is in my opinion the coolest feature about this synthesizer. Starting from the left, we have a sensitivity control, which controls sensitivity. Now, the first routing option that we have for touch effect is volume. I can push down the key just like normal, but if I give it a little bit extra, that's our aftertouch effect. You can kind of see where it naturally bottoms out right here, and when the aftertouch kicks in. So then again, the first control is volume. The next one is wow. Crank the sensitivity up on that. After that, we have something called growl. We have vibrato. And pitch bend, both up and down. And if you'd like, you can combine them all together to make some sort of crazy effect. And there we have it, a brief tour of the Roland SH-2000. Now, although I didn't end up using the homebrew ports on the side or on the back, it could lead to a modification of this synth in the future. So we'll have to see about tackling that some other time. But for now, Mara, your synthesizer is all fixed up, so let's do a little music demo with it.